Module 8, Lesson 3 dives into the world of triangles with a suggested pacing, claiming this is going to be a 2-day lesson, 15 resources. I'm not real confident in that. Sailboats use triangular sails to catch and use power of the winds to propel the boats. The size of the sail depends on the size of the boat. Sometimes a boat needs to change a sail so large that it may become challenging to handle. In these cases, the boat may use several smaller sails or of different sizes. The size of the sail depends on the angle measures and the side lengths of the triangles used to create the sail. Suppose you need to buy a sail for your sailboat, and you're told your sail needs to have angle measures of 35 degrees, 55 degrees, and 90 degrees. Do you think that is enough information to buy the correct size sail? What do you think? Not even close. We're going to learn more about this concepts when we dive into this lesson. Our inquiry question for this lesson asks, how do you know whether or not it is possible to create a triangle given 3 side lengths or any 3 angle measures? They've got 11 slides in this, so maybe this is going to be worthwhile. In the demonstration, you can see that a triangle is created when all 3 sides measure 15 units. Use a sketch to see if you can create a triangle with sides that measure 4, 5, and 8 units. So let's see what they're saying here. So when we had all 3 sides measuring 15 units, that would have been something like, I'm really confused, so hold on. Alright, I think I know what they want us to do. So we're going to take this shape here, and we're going to take and connect it to this shape here. We're going to add a line in. Whoop, how are we going to do that? Okay, yep, something like that. And then we got this one here that we're also going to need to create a line with, and we want to know, is there a way to make a triangle out of that? Well, there is. We're just going to have to take and connect the dots pretty about like that. So yep, that one there is going to make a triangle. Now the question is, what other triangles could we make out of this? And there really isn't any others. We could flop the way or turn it around how it's set up, flip it over, but that's going to be it. Take for example the 15. There's no way that I could take and put 2 angles together and have it equal 15. Because let's see right here, if I did that and I swung those over to there, those were my 2 longest pieces, and those 2 longest pieces do not equal 15. So what do we know? We know that the sum of the side lengths have to equal something less than the total number given. That's based off of the number of angles, so we can say that you can only create one triangle, one unique triangle out of this. Let's see what else the next resource says. Now the next one only gives us these 3 angles, and they want us to be able to complete a triangle based off of that. And we're going to see, we've already actually done this once, that there's no way we can make a triangle out of that, because the 2 side lengths add up to be something smaller than the 3rd side length. So we have to have the 3 side lengths set up to where any 2 of them added together equals a number that is equal to, or actually be greater than, the side length given. So for this one, there's going to be 0 unique triangles that we can create. Alright, now we're going to take and try another one. This time they want us to take and use any of the lengths to create 3 different triangles, and once again, we're not going to waste a lot of time on that. The big thing is that whatever lengths you pick, the 2 shorter sides have to add up to be greater than the long side. That's the whole point of this activity. Now in classifying the triangles, we get a whole bunch of vocabulary terms. First off, an acute triangle is a triangle with 3 acute angles. None of the angles is greater than or equal to 90 degrees. An obtuse triangle is going to have 1 angle that is going to be greater than 90 degrees. A right triangle is going to have 1 angle that's going to be exactly 90 degrees. Now we can go beyond that and talk about the scalene triangle. In a scalene triangles, all three side lengths are going to be different. With an isosceles triangle, you have two side lengths that are going to be exactly equal, and then finally the equilateral triangle, that's going to be a triangle in which all three side lengths are exactly equal. And an interesting side note, in an equilateral triangle, you've got all three angles are going to be exactly equal or congruent as well. Now this part over here is pretty important too. It tells you that you can indicate congruent sides by the number of tick marks in them, and hopefully they'll give us some demonstrations of that in the lesson, where if you have two sides that have one tick mark, you know those two sides are congruent or equal. If you have sides that have two tick marks and sides that have one tick mark, the one tick marks are congruent and your two tick marks are going to be congruent as well. From here, we're going to select some triangles to see how they're going to classify. Example of an acute scaling, you can see that all the angles are less than 90 degrees and all the sides are different length. An acute isosceles, all the angles are less than 90 degrees and two of the sides, you see the pink tick marks there, are going to be congruent or equal. And then for the equilateral triangle, you've got all three sides are going to be congruent and all three angles are going to be less than 90 degrees as well. Next, for the right scalene, you have a one right angle and the side lengths are different. For a right isosceles, you have one right angle and the side lengths are going to be you have two side lengths that are going to be equal. And then for the right equilateral, it doesn't exist. There's no way you can do it. Moving on to the obtuse. For the obtuse scaling, you've got all sides are going to be different length and the largest angles can be greater than 90 degrees. For the obtuse isosceles, you have two sides that are going to be congruent and the largest angle is greater than 90 degrees. And once again, it is impossible to make an obtuse scaling triangle. Okay. Now we're going to take and learn how to draw freehand a triangle given various information.
Draw triangles freehand. You can draw triangles freehand without the use of a straight edge. Draw a scalene triangle. First, draw two sides of different lengths to form the first angle of the triangle. Then, connect the two segments to form a triangle, making sure the third side does not appear to be the same length as either of the other two sides. This is a scalene triangle. Because one of the angles is an obtuse angle, it is an obtuse scalene triangle. Now, draw a right isosceles triangle. First, draw a right angle. Draw the line segments so that they appear to be the same length. Then connect the two segments to form a triangle. Label the right angle.
Now it would be a good idea to put a tick mark in each one of these two congruent sides as well.
Place tick marks on the segments with the right angle to show that they are congruent. This is a right isosceles triangle.
Well, that was about as exciting as watching paint dry. Next, our instructions tell us to draw a triangle with one obtuse angle and no congruent sides. So what are they asking for? They're asking for an obtuse scalene triangle. And then it says to classify the triangle by its sides and its angles. So they want us to actually say it is an obtuse scalene triangle. Then determine if these characteristics create a unique triangle or more than one triangle. So from here, let's keep moving. We're going to start off by drawing our triangle, and they say that the obtuse triangles can be greater than 90 degrees, but less than 180 degrees. And it says that they want us to choose from the dashes to figure out one of the options here. So I'm going to take and, not sure how I was supposed to choose that dash there, but yep, that's the one we want. That's going to be our obtuse angle that we got. From there, we're going to take and, Yep, I guess move on to the next slide here. Now that we've got our obtuse angle, then we're going to end up tracing the first side length. So in doing that, we're going to click that right angle again. And that's going to end up giving us that. Let's see what it says next stroke. Oh, there we go. Now I found something. It says trace the second side, and because no angle has congruent sides, the two sides of the angle should be different side lengths. So we can see how we made where they've got different side lengths. And then from there, draw the triangle to finish it up, and you ended up getting your obtuse scaling triangle. So what do we know? We know it's obtuse, and we know it's scaling. Check the answer. Not really hard concepts to work with here. Would encourage you to use a straight edge if you have one to make your drawing a little bit easier, but in the end, it's going to be pretty simple. Next, they want you to draw your own triangle freehand. We're going to draw a triangle with 3 acute angles and 3 congruent sides. That means that we're going to be drawing an acute equilateral triangle, and then you're going to do all that classifying stuff and things of that nature that we did before. So let's see how bad my drawing skills are, because I know my drawing skills are really bad, but I may be able to help it out if I use a straight edge here. So I'm going to have to come up with 3 acute angles, or 3 acute equal side lengths. So let's take this, and I'm going to come down to right about there, which is going to give me 1, 2, 3 inches. And then I'm going to take and do another one of those. So I'm going to take and maybe if I move things over here, it'll give me another side length, and then worry about connecting those side lengths. And then I'm going to do another one here, and I'm going to give myself the same side length. So there's going to be my 3 congruent side lengths. Turn off my turn off my whatchamacallit there, ruler, and now I'm going to take and start connecting those 3 congruent side lengths. And unfortunately, it appears that 2 of them are connected to each other. Oh no. Alright, I made them to where they're not connected to each other anymore. Now I'm going to take and worry about trying to rotate them and connect them. And this can be kind of hard to get this perfect on a computer, but we're going to get it pretty dang close. Where, wait a minute, there is no way that side length is the same. I must have made it smaller as I was moving it. So it's going to be something along the lines of that. It's going to be close. Wow, that's really pretty horrible. That one got stretched too. So, yeah, that's fairly close there. From here, all we have to do is put the tick marks in right there to show that those 3 side lengths are going to be congruent. Probably a lot easier to do on a sheet of paper with a real ruler. So what do we know about it? We know that it's an acute equilateral triangle, and then say, is it possible to draw a different triangle with the same characteristics? And the answer is not really. I mean, you could choose different sizes for the side lengths, but in the end, that's the only option you could make. I think this is going to be a good spot to stop part 1 of this video. Come back to part 2 as we continue our study of triangles.